determine the following limits at infinity. Okay. Again, for limits, you can always try to do the substitution first. Right? But whenever x is approaching positive or negative infinity, things get a bit trickier. Because here, if you do the substitution, right, theoretically, something very, very large minus 4 is still very, very large. Right? Something very, very large times 3 plus 5, it's still very, very large. Right? So if you do the substitution, it's like infinity over infinity. Okay, later we're going to use the L'Hopital's rule, but now, first we are going to just divide both sides by x to the highest power. Okay, we do this whenever we do the substitution and we see a pattern infinity over infinity. Okay, so ask yourself, what's the highest power of x on the top? It's just 1, right? And what's the highest power of x on the bottom? It's also 1. So just divide the top by 1, sorry, by x to the power of 1. You divide the bottom by x to the power of 1. Okay, then you will see the top. It's 3 plus 5 over x. The bottom is 1 minus 4 over x. Okay. Now if you do the substitution when x is very, very large, 4 over x is very, very close to 0. Right? 5 over x is very, very close to 0. So it's just 3 plus 0 over 1 minus 0. Okay, the result is 3. So you do this, divide both sides by x to the highest power. Whenever you do the substitution, you see an infinity over infinity case. Okay. So let's quickly do part B. So it's a limit x cubed minus 2x plus 3 over 5 minus x squared. 5 minus 2x squared. Okay, again, do the substitution. The top, right? Even if it's minus 2x, but you can see x cubed is always much larger than 2x, right? Especially when x is very, very large. So the top, if x is very, very large, the top is still going to be very large. And the bottom, when x is very large, 5 minus 2x, right? It's going to be a very, very small. It's close to negative infinity. So again, you can divide both sides by x to the highest power. Right? So here, the top x, the highest power is 3. Right? The bottom x, the highest power is 2. So just divide both sides by x to the power of 3. Okay, 5 over x to the power of 3 minus 2x squared, x to the power of 3. Okay, you'll see here the top is 1 minus 2 over x squared plus 3 over x cubed over, okay, 5 over x cubed minus 2 over x. Okay, now you see the problem. When x is close to infinity, okay, here it's 1, but all the other parts, they're close to 0. Okay, they're close to 0. So the top, there's nothing special about the top, right? It's just 1 minus 0 plus 0, okay? But what about the bottom? We know it's 0 minus 0, so the result must be 0. But it's approaching 0 from a positive side, or from a negative side. That's very important, okay? Because if it's 1 over, positive 0.001, then it will be like positive infinity. But if it's 1 over negative, like 0.0001, it will be negative infinity, okay? So you have to figure out whether the bottom is approaching 0 from the left or from the right. Because your answer will be different. Your answer will be positive infinity or negative infinity. Okay, so how do we figure it out? Okay, how do we figure it out? So you can do this, right? You have a common factor 1 over x. You extract it, then it will be 5 over x squared minus 2. Okay, then you can do this analysis. This 1 over x, this will always be positive, right? Then this 5 over x squared, this is closer and closer to 0. Then minus 2, right? This part is closer and closer to 0 minus 2, right? This part is closer, this part is negative, okay? So the product must be negative. Okay, so this is very, very important. So the bottom is approaching 0, but from a negative from the left-hand side, which means it will be like negative 0.001. It will be a negative number slightly smaller than 0. So that's why the ratio in the end, there will be negative infinity. Okay, you have to be careful with this. Do you have any questions for this part? Yeah. Yeah, you can also do that. Just do the long division. Yes, you can also do the long division first, right? And then it will be like a constant plus a fraction. Then you can just do it. Okay. So that's question. That's part B. So part C. You can see part B, same concept, but more details. Right? Part C, now it's x plus 2 over square root of 9x squared plus 1. Okay. So here, again, if you do the substitution, it will be positive plus 2 on the top. Right? Bottom, it will be like positive plus 1 square root. It's still going to be positive infinity, right? Positive infinity. So you want to divide both sides by x to the highest power. So now the question is, what's the highest power? So on the top, the power is 1. It's quite clear. But on the bottom is a power x squared. Is a power 2? No, because you first x square, then you take a square root. Okay, so essentially you square it first and take the square root, the power is still 1. Okay, so if you divide both the top and the bottom by the highest power, you don't divide by x squared, you divide by x. Okay, because the bottom, the power is still x. Right. Then another thing is, for the top, it's very easy to simplify. For the bottom, right, when you move a number into a square root, what should you do? Okay, that depends. If this is a positive number, so let me write it down here. If it's a positive number, like 2 square root of 3, right, if you want to move 2 into the square root, you just need to square 2, right, times 3. It's done. Okay. It's very important. Let me put it down here. Okay, but if it's negative 2 times square root of 3, okay, can you do the same thing? Can you just square negative 2 into the square root and say, okay, that's it, finish? No, right? Because here, the left-hand side, it's a negative number. Now, if you're writing this way, it's a positive number. Okay, the difference between the left and the right is a negative sign. So you have to put an extra negative sign in front if this number is negative. Okay, so if you want to generalize it, for example, a square root of b is, it's just square root of a squared b if a is positive, right? And it's negative square root of a squared b if a is negative. Okay. Of course, when a is 0, it's just 0. We don't have to do anything. So So whether a is positive or negative, it matters. Okay, it matters. Right, so here, is this 1 over x positive or negative? Okay, that depends on whether x is approaching what number. Right? Here, x is approaching positive infinity. That means x is always positive when x is closer and closer to positive infinity. Right, so this 1 over x is positive, so you can just move it in, and it's 1 over x squared times 9x squared plus 1. Okay, then just keep simplifying it. It's square root of 9 plus 1 over x squared. Then when x is approaching positive infinity, this part is 0, this part is 0. So you get the answer. It's 1 over square root of 9. Okay. Do you have any questions for this part? Okay, you can see part D is the second case we're talking about. All right, so let's do part D. In part D now, x is approaching right? Sorry. Let me quit this. Okay. So in part D, it's a limit x over square root of x squared plus 4. Okay, when x is approaching negative infinity. Okay, so now what's the highest power for the top? It's 1. Okay, again, you do the substitution. If you do the substitution, it's negative infinity. The bottom is negative infinity, right? Square, so it's positive infinity plus 4 square root, whatever. It's still positive infinity. So it's negative infinity over positive infinity. So you can apply the method, divide both parts by the highest power. So now, again, the top, the highest power is 1. The bottom, the highest power, it looks like it's 2, but you are actually squaring root of x squared. So the power is still 1. So you divide both sides by x. Okay, you're dividing both sides by x. Then the top is 1. The bottom is... Okay, so now that's this part, right? If your a square root of b, if your a is a negative number, you put a into the square root, you have to put an extra negative sign in front, right? Because here, your x is approaching negative infinity. So 1 over x, it is approaching negative infinity. So it's a negative number. So you want to move 1 over x to the bracket, to the square root. You have to put a negative sign in front. Okay, you have to put a negative sign in front. So it's a limit, x is approaching negative infinity, 1 over negative square root of 1 plus 4 over x squared. Okay. And now do the substitution when x is positive or negative infinity, this fraction is 0, so it's just 1 over square root of negative 1 plus 0. So the result is just negative 1. Okay. Okay. So let's do part T. Okay, part E is a limit square root of x to the power 4 plus 6x squared minus x squared when x is approaching infinity. Okay. So again, do the substitution when x is approaching infinity. Here, this first part is infinity minus the second part, it's infinity. You can never ever treat infinity like a number. Okay, never ever say, okay, it's infinity minus infinity, so it's 0. Okay, it's wrong. And why it's wrong? Because you are treating infinity as a number. The infinity is a mathematical concept. Okay, it's not a number, like a number 2, number 3, number 5. Okay, don't ever do that. Similar mistake would be like infinity over infinity is just 1. Okay, it's wrong. Again, you're treating infinity as a number. You're cause mistakes. But for example, if you are 1 over something approaching infinity, yes, you can make the conclusion it's 0. Okay, this type is fine. Okay. So here, if you do the substitution, it's infinity minus infinity. So you don't know the answer. Okay. So what you can do is you can create a fraction, right? You can create a fraction. So how do you create a fraction, right? Whatever you're dealing with is like a fraction over 1, right? It's itself over 1. So you can create a fraction out of nowhere, and then you can multiply, because here you have a annoying square root. Okay, so you can multiply the conjugate of the top. You can multiply the square root plus x squared. Okay, so first you can treat it as this over 1, then you can multiply both sides by the square root plus x squared. Okay, plus x squared. So here the bottom is also 1 times the square root plus x squared. Okay, then just do it. A plus b times a minus b is a squared, right, minus b squared. Okay, so that's after you've done the top, it's a minus b times a plus b. It's just a squared minus b squared, right? Then, okay, these two parts, they cancel out, so we can remove them. Okay, now if we do the substitution, it's 6, right? 6 infinity squared is still infinity. The bottom, quite clear, it's still infinity, right? But now, since it's a fraction and both sides are approaching infinity, you can divide both sides by the highest power. Okay, you can just divide the top by, here the top highest power is x squared. The bottom, the highest power is also x squared. Right, so 6x squared over x squared. The bottom is 1 over x squared times the whole thing. Okay. Then this will be limit x approaching infinity, 6 over, so again, you move 1 over x squared into the square root, and now x is a positive, 1 over x squared is a positive thing. So It'll be 1 over x squared times x to the power 4 plus 6x squared. Okay, plus 1. Okay, just finish our calculation. Okay, finish our calculation. It is here when x is approaching infinity, right, this is approaching 0, so it's just 6 over 1 plus 1. Right? It's going to be 3. Okay. Do you have any questions for this part? Right, let's quickly do the last two questions. F, limit e to the power of 3x minus e to the power of negative 3x over e to the power of 3x plus e to the power of negative 3x. Okay. When x is approaching infinity. Again, do the substitution. It's infinity here when x is approaching infinity, this part is 0. Okay, then here it's infinity plus this part is 0. Okay, then it's still infinity over infinity. Okay, here you cannot divide by x to the highest power because it's not a polynomial anymore, but you can divide e to the power of 3x, right? So you can divide e to the power of 3x. Okay, you can divide e to the power of 3x. So the top is just 1 minus e to the power of negative 6x. The bottom is 1 plus e to the power of negative 6x. Now when x is approaching infinity, this part is e to the power of negative infinity. It will be 0. Right? So now if you do the substitution, it will be 1 minus 0 over 1 plus 0. It's 1. Okay, last one. X approaching infinity ln 2 plus x minus ln 1 plus x. Okay, first ln a minus ln. First do the substitution, right? Here it's ln infinity, it's still approaching infinity, minus ln infinity, it's still approaching infinity. So again, it's infinity minus infinity. So out of all the questions in problem 1, right, we create fractions. So for ln, we also create fractions. Create a fraction. Remember ln a minus ln b, it is ln a over b, right? So it is ln 2 plus x over 1 plus x. Okay, and remember from last tutorial, because ln is a continuous function, right? So the limit of a continuous function is a continuous function of the limit. So you can swap these two things. You can swap the order of your calculation. So it can be changed to ln limit x plus 2 over x plus 1. Okay, then this part is very standard, right? It's infinity over infinity. So you divide both sides by the highest power. So it's a limit x approaching infinity, right? You divide by x, it will be 1 plus 2 over x. It will be 1 plus 1 over x. Okay, so what's inside, it's going to be 1. So it's ln 1. It's just 0.